All right, so what we're going to learn now is 3 types of solutions. We're going to look at ones that are one solution, ones that are no solution, and ones that are infinitely many. Hey guys, it's me, Miss Doolittle. So today we're looking at the 3 types of solutions for a system. The first one we have here, which you can see, is one solution. This is when 2 lines intersect at only one point. Okay, so now let's see it algebraically. I'm going to do this problem by using elimination. So first thing I'm going to do is I'm going to rewrite both of my equations, and then I'm going to look to see which one I can eliminate. My x's are set up for me to eliminate. They're opposites, so they're nice and easy to cross out. Now I have y minus negative 4y, which is going to get me negative 3y equals, and negative 1 technically plus 4 is going to get me 3. I'm going to divide both sides by negative 3, which is going to get me y equals negative 1. Now I can take this information and I can plug it in for y into either equation. I'm just going to choose the first equation because I think it's a little bit easier to work with. 6x plus negative 1, which is really just minus 1, is equal to negative 1. Now I'm going to add 1 to both sides of my equation, and I'm just solving it like a normal equation now. 6x equals 0. I'm going to divide both sides by 6, and x equals 0. Now that I have both of my ordered pairs, I can write my solution, which is always x and then y. 0, because that's x, and y is negative 1. That's the solution. As you can see, they only intersect at the one point. Check this out. Just before, when I did it algebraically, I got the answer 0, negative 1. And now over here, I've graphed it for you, and I also got 0, negative 1. I'm going to get the same answer no matter which way I do it. Oh, this time now, we're going to have no solution. And what this means is I have 2 parallel lines, and they never intersect. So it's impossible, meaning I have no solution. Hey guys, so what we're going to do now is we're going to solve no solution from an equation. First thing I'm going to do is I'm going to rewrite both of my equations. And once I rewrite both of my equations, I'm going to use elimination. That means I need to pick which variable I'm going to try to eliminate, the x's or the y's. I'm going to try to eliminate my x's. I have a negative 3x and a negative 1x. So I'm going to have to multiply the bottom of the equation by a negative 3. When I do that, my x's are going to eliminate. First, I'm going to rewrite my first equation just so it's there and they're next to each other. Negative 3 times negative x, well, that's going to be a positive 3x. Negative 3 times y, well, that's negative 3y. And negative 3 times negative 3, that's negative 9. And check this out, my x's are going to eliminate and my y's are also going to eliminate, which is going to get me 0 equals negative 5. Well, does 0 equal negative 5? No. So my answer is no solution. Check it out, I took those 2 same lines and now I graphed them, and look, they created parallel lines, meaning they're never going to intersect. So that's why it makes sense that there was no solution before. Okay, and this is the third type of solution we're going to see, infinitely many solutions. And what this means is I have the exact same line. I have the same slope and the same y-intercept, which means I actually have the same line, which means I have infinitely many solutions. All of the points on this line is where they are going to intersect. All right, so what we're going to do now is we're going to see infinitely many from an equation. First thing I'm going to do is I'm going to rewrite both of the problems. And once they're both rewritten, I'm going to start to think about, am I going to use substitution or am I going to use elimination? I'm going to choose to use elimination for this method. What I'm going to do is I'm going to multiply the bottom by 2, and I'm going to multiply everything by 2. I'm going to rewrite my first equation just so it's there for me and nice and neat. And now when I multiply it by 2, what am I going to get? Well, 2 times negative 7x is negative 14x. 2 times positive 2y is going to get me positive 2y. And then 2 times negative 23 is going to get me negative 46. And something very interesting happens. Check this out. Everything actually eliminates, leaving me with 0 equals 0. Is that true? Yes, it is. So my answer then is infinitely many solutions. That's all. As you just saw algebraically, I got infinitely many solutions, and now when I graph them right here, it turned out to be the exact same line, which means they have infinite points in common. That's how we got our answer.